small to be detected. Time-traveling electrons. Another way scientists have tried to observe the electrons' superposition in the double-slit experiment was to observe them after they had passed through the slits. So they placed detectors in between the barrier and the detector at the back. The reasoning was that as the electrons passed through the barrier, their waves would have split as there was no measuring happening while they went through. And then when they were measured past the double slit, the electrons would be found across the length of the area behind the double slit barrier and in correspondence with the final interference pattern. But that didn't happen. In fact, when they did the experiment, the electrons were found only in the areas directly behind the slits, and no interference pattern emerged on the back detector. Stranger still, when the detectors were switched off, the interference pattern returned. When scientists weren't looking for the electrons, they continued to exhibit their wave-like properties and land on the back detector to produce the interference pattern. But when the electrons were observed, they collapsed back to a particle and eliminated all evidence of the superposition by not being detected anywhere but behind the slits. So the scientists attempted to outsmart the electrons and decided not to have the detector switched on until after some of the electrons had passed through the slits. But even when they did that, the electrons somehow knew that the scientists were going to switch the detectors on, and the superposition collapsed. There was no interference pattern and electrons were only found behind the slits. Every time the scientists decided to leave the detectors off for the whole of the experiment, the interference pattern emerged. And every time the scientists decided to turn the detectors on midway through the experiment, the interference pattern no longer appeared. So it was almost as if the electrons were going through the slits with their wave function intact, and as soon as they realized that the detectors were going to be switched on, they went back in time, reverted back to particle-like behavior, and erased all evidence of the superposition. So what's actually going on here? Are the electrons actually time traveling? Well, quantum mechanics says that the electrons did not go back in time, but that they did in fact go through both of the slits at the same time, but that as soon as the detectors were switched on, the electrons collapsed their wave functions, choosing to be in line with one or other of the slits and erasing all evidence of their superposition.